You know those incredibly powerful AIs we use every day? What if I told you they're, well, surprisingly forgetful? Today, we're going to dive into a really clever shift in AI design that gives these models something like a long-term memory, making them not just bigger, but fundamentally smarter. So, to really get why this is a game changer, we have to start with the main problem. At their core, a lot of today's big language models are just incredibly inefficient. I mean, they burn through a massive amount of energy doing tasks that should be simple, basically repeating the same work over and over and over again. Imagine this. Every single time you saw the word the, you had to sound it out letter by letter. T-H-E, instead of just instantly recognizing it. Well, that's pretty much what current AI models are doing. They are constantly rebuilding super common phrases and ideas from the ground up, and it is a colossal waste of computing power. The solution, it turns out, is both elegant and really intuitive. You just give the model a memory. And that's the whole idea behind what's called conditional memory, giving an AI the ability to just look up information it already knows instead of having to recalculate it from scratch every single time. This new superpower is made possible by a module called an Engram. The easiest way to think of an Engram is like a super fast librarian living right inside the AI. Its one and only job is to fetch common phrases and facts from this huge memory bank, so the main model doesn't have to get bogged down with all that repetitive work. So what is this librarian actually fetching? Well, it's grabbing a ready-made vector. That's just a technical term for a numerical recipe for a concept. So instead of, baking the cake from scratch every time, the AI gets the finished product delivered right to it instantly. Okay, so let's get into the nuts and bolts of how this incredible process actually works. It's a surprisingly simple 5-step dance that happens in, the blink of an eye, and it makes the entire model way faster and more efficient. So here's the high-level view. First, the model spots a familiar phrase. Then, it instantly finds where that phrase lives in its memory, grabs the pre-made information, does a quick check to make sure it's actually relevant, and then seamlessly blends it into its current line of thought. Let's break down each of those steps. It all starts with a tiny pattern. As the model is processing text, the Engram module is just looking at the last 2 or 3 words. That's what we call an Engram. This small string of words is the trigger. It's the cue for the AI to go, hey, should I check my memory? Next up, a hash function kicks in, and this thing acts like a super efficient GPS. It takes that word pattern and instantly converts it into a unique numerical address in the AI's massive memory bank. It's like having a perfect index for an enormous library that points you to the exact shelf every single time, with no searching. Now that it has the exact address, the system just pulls the pre-computed vector from that spot in memory. This is that finished recipe, the numerical representation of the phrase, all ready to go. But this part right here, this is the really clever bit, the gating mechanism. See, the model doesn't just blindly use every memory it finds. A small, intelligent gate analyzes the current context, what the AI is thinking about right now, and decides if the memory is actually relevant. If the phrase fits, the gate opens. If not, it stays shut. This makes the system incredibly smart and adaptable. And finally, if the gate gives the green light, that approved memory vector is seamlessly fused into the AI's ongoing chain of thought. It's kind of like adding a perfect new brush stroke of color to a painting. It enriches the final picture without you having to mix the paint from scratch. This whole process introduces a completely new way for AI to be efficient. It's a concept called sparsity, which is just a fancy way of saying the model only activates the specific parts it needs for any given task. It's like walking into a huge house and just turning on the light in the one room you're in, instead of lighting up the entire place. Now, this is where Engram really shines, and it's different from another popular technique you may have heard of called mixture of experts, or MOE. MOE is all about picking the right expert for a complex job. Engram is about looking up a known fact. So one is conditional computation, while the other is conditional memory. But here's the best part. They're not competitors. They're collaborators. An AI can use its MOE experts for the really heavy-duty complex reasoning while using its Engram librarian for all the quick memory lookups. It really gets the best of both worlds. So what's the bottom line here? What does the Enneagram advantage really get us? Well, it doesn't just lead to bigger AI models. It leads to AI that's fundamentally smarter, faster, and way more efficient in how it actually thinks. By offloading all that repetitive work, Engram frees up the AI to focus on what really matters. Deeper reasoning, better factual recall, and understanding the big picture. It's like having a super efficient assistant that handles all the small stuff, so the main intellect can focus on the big, important decisions. And the real magic here is its speed. The lookup process is what engineers call constant time, or O of 1. All that really means is that no matter how massive the memory gets, billions or even trillions of entries, the lookup time stays exactly the same. It's instantly fast every single time. Ultimately, this all points to a really powerful truth about where AI is heading. The future isn't just a race to build bigger and bigger models, it's about smart design. By intelligently balancing memory and computation, we're creating AI that's not only more powerful, but more efficient and, more capable of solving the world's really big challenges.